Hi there. This interview simulation focuses on API failures and rate limiting in real production environments. We will look at how services behave under load, how failures cascade, and how teams make decisions when traffic patterns become unpredictable. Before each answer plays, pause the video and give your own response out loud as if you were in an actual interview. It is one of the best ways to build confidence and speed. If you want more long-form DevOps interview simulations like this, make sure to subscribe so you do not miss the next one. Let's start with a few warm-up questions. Tell me about a time when an external API failure affected your system. What happened and how did you respond? A strong answer would sound like this. We relied on an external payment provider that slowed down during peak hours. Even though our system was healthy, our request queue grew and users experienced long delays. Instead of retrying aggressively, we implemented back-off and fallback responses so the system would not collapse. Long-term, we added better monitoring and alternative flows to reduce dependency on a single provider. It taught me that external APIs can behave like internal dependencies and must be treated with the same caution. Next question. Describe a moment when you had to communicate an API failure to stakeholders who were not technical. A solid response would be, we had an outage where our authentication provider was rejecting requests. Users could not log in, but the rest of the system was fine. I explained the situation to stakeholders using simple terms. I focused on what users were experiencing, what we were doing to reduce impact, and what users could expect next. Clear communication prevented confusion and reduced pressure on the engineering team. Another question. Tell me about a situation where rate limiting surprised your team or caused unexpected behavior. A good answer might be, we once hit a rate limit in our email provider because of a spike in signups. The limit was silent, meaning we got delayed deliveries rather than explicit failures. It confused us until we checked the provider metrics. After that, we added internal rate limiting and better batching. It reminded me that rate limits must be understood clearly, not assumed. Next warm-up question. How do you handle disagreements about how much retry logic to add to a service? A strong response would be, I bring the team back to the principle that retries can help, but they can also cause damage. I ask whether the service we are calling is safe to retry and whether our retries could amplify an outage. I encourage the team to use data, not instinct, when choosing retry patterns. This helps balance reliability and safety. One more warm-up. Tell me about a lesson you learned early in your career about API failures. A thoughtful answer would be, I learned that not all failures look like failures. Timeouts, slow responses, partial errors, and silent rate limiting can be harder to diagnose than hard failures. Monitoring and fallback logic are just as important as correct request handling. Let's move into the first half of the technical section. Explain what an API rate limit actually protects. A strong answer would be, a rate limit protects the upstream service from being overwhelmed. It ensures that no single client or group of clients consumes more than their fair share of resources. It also safeguards the system during spikes, so capacity can be shared fairly. For the client, rate limits mean you must design for controlled retries and graceful degradation. Next scenario. Your service makes requests to an external API and starts receiving a mix of timeouts and slow responses. How do you diagnose the issue? A solid response would be, I start by checking whether the timeouts happen at consistent intervals. If they are sporadic, it might be a network issue or load-related. If they rise gradually, the provider may be experiencing overload. I compare client-side timing with provider status. Then I inspect whether our own retry logic is adding pressure. Sometimes clients amplify a small problem by retrying too fast. Next question. Your team wants to disable rate limiting temporarily to handle a spike in traffic. What is your perspective? A mature answer would be, rate limiting exists to protect the system during spikes. Disabling it during a peak is like removing a circuit breaker during an electrical surge. Instead of disabling it, I suggest adjusting the thresholds using queues or offloading work. Removing rate limits entirely can create a cascading failure. Next scenario. You see that your system is hitting the rate limit of a third-party API. You cannot increase the limit. What options do you consider? A thoughtful answer would be, I look at batching requests, caching responses, reducing unnecessary calls, and introducing internal rate limiting to smooth out spikes. If the limit is still too small, I evaluate whether we need a different workflow that does not rely on that API in real time. Sometimes the best fix is to alter user flows so the dependency is less direct. Next question. Imagine your service receives a burst of traffic that exceeds your own API rate limit. How do you choose between rejecting requests immediately or queuing them? A strong answer would be, if the workload can tolerate delays, I queue requests with a clear timeout. If the requests are user-facing and delays cause confusion, I return a clear error. Queuing is helpful when the system can catch up, but dangerous when the queue grows without bound. The decision depends on the expectations of the client and the stability of the backend. Next scenario. Your service depends on a third-party API that enforces a strict per-minute limit. During a peak event, your traffic doubles and you begin hitting the limit hard. You cannot raise the limit and you cannot disable the dependency. How do you redesign the system to handle this safely? A strong answer would be, I start by smoothing out the traffic. Bursty traffic is the fastest way to hit hard limits. I introduce internal rate limiting so we do not exceed the third-party constraints. Then I look at caching responses, so we reuse data instead of calling the API repeatedly. If the API supports batching, I batch multiple calls together. If not, I redesign the workflow so only essential operations touch the third party. Sometimes this means shifting work to asynchronous queues, so calls happen gradually instead of all at once. The idea is to reshape the load so our usage stays within the limits while users still get responsive behavior. Next scenario. You notice that your service is using exponential backoff retries, but during a major outage at the provider, your system still contributes to a retry storm. What do you look at? A mature answer would be, I first check whether the retry logic includes jitter. Without jitter, exponential backoff still causes synchronized retries across many clients. Next, I look at the maximum retry count. If it is too high, clients keep hammering the failing provider even after it is clear they will not succeed. I also check whether the retries propagate upward. Sometimes a single user action triggers multiple retries across multiple layers. Finally, I consider whether circuit breaking is needed. A circuit breaker stops retries once the system detects that the upstream is consistently failing, which prevents the entire client fleet from adding pressure. Next question. Your API receives different types of requests. Some are cheap and fast, while others are heavy and slow. You need to implement rate limiting. Do you rate limit all requests equally or use different buckets? A thoughtful answer would be, I use separate buckets. If heavy requests consume more resources, treating them equally can starve lighter requests. I classify by cost or priority and set limits accordingly. For example, metadata reads may have a higher limit, while write operations or expensive queries have stricter thresholds. This ensures that one type of workload cannot overwhelm the entire system. It also makes user experience more predictable. Next scenario. Your service calls an external API with a limit of 1,000 requests per second. You are using a shared API key across multiple microservices. Suddenly, you hit the rate limit and several services break at once. How do you isolate and solve this? A strong answer would be, using a shared key creates a shared failure domain. I separate the API keys by service or purpose. That way, one noisy service cannot consume the entire quota. Then I add per-service rate limiting so we can see exactly where the excess traffic is coming from. Once the problem service is isolated, I analyze its traffic pattern. It might be retrying too aggressively or calling the API unnecessarily. The ultimate goal is to prevent a single service from collapsing the whole ecosystem. Next scenario. You are designing a public API. Each customer has a different traffic pattern and different business importance. How do you choose a fair and safe rate limit strategy? A mature answer would be, I combine global limits with customer-specific limits. Global limits protect the back end, while customer limits ensure fairness. I also provide higher tiers for premium customers and lower tiers for casual use. The key is providing predictable behavior, so customers know what to expect. Documentation needs to be clear and precise. Internally, I monitor usage to detect abuse or anomalies. A one-size-fits-all rate limit rarely works in a multi-tenant system. Final question for this section. A downstream service is slow but not failing. Requests pile up and your queue starts growing. You are not hitting a rate limit, but the system is degrading. How do you prevent a slow service from becoming a total outage? A strong answer would be: slow responses can be more dangerous than hard failures. I use timeouts that reflect realistic performance expectations, not overly generous ones. Then I apply bulkheads so only a portion of the system is affected by the slowdown. If the service is consistently slow, I enable circuit breaking so requests fail quickly rather than piling up. I also decouple the work so slow tasks move to asynchronous pipelines when possible. The goal is to protect the overall system even when one part is struggling. Let's step into some high-pressure, ambiguous scenarios that test judgment rather than just technical knowledge. Imagine your system starts receiving intermittent 429 responses from a critical third-party API. The alerts are firing, customers are complaining, and traffic is already high. You do not yet know if the issue is on your side or theirs. What is your very first move? A calm and mature answer would be: my first step is to stabilize the situation. I apply an internal rate limit to smooth out our outgoing traffic and prevent making things worse. At the same time, I gather signals from our monitoring, logs, and metrics to understand if our own call volume has changed. I do not assume the fault is external or internal without evidence. My goal is to slow the system down just enough to buy time for investigation, without fully shutting it down. Once the immediate pressure is under control, I start comparing usage trends to the third-party limits, check recent deployments, and look for user behavior spikes. Stabilize first, diagnose second. Next scenario: your service depends on a payment API. During a promotional event, the payment provider begins responding with long delays and occasional failures. Leadership demands an immediate fix, and customers are stuck at checkout. You have limited visibility into the upstream system. What do? A thoughtful answer would be: I prioritize keeping the customer experience alive, even if it means accepting some temporary degradation. If possible, I switch to a degraded workflow, such as capturing the order and processing payment asynchronously when the provider recovers. If the business rules allow it, I introduce a queue for payment attempts so customers are not blocked at checkout. I also set aggressive but fair timeouts so requests fail quickly instead of hanging. Throughout the event, I keep leadership informed with clear expectations. The goal is to keep the user journey moving while protecting our backend from slow upstream behavior. Next question. You have a shared API limit across multiple teams. One team repeatedly pushes traffic spikes that cause everyone else to hit limits. You cannot enforce an architectural change immediately. What is your judgment call in the moment? A strong answer would be: in the short term, I protect the platform and the users. I introduce temporary per-service throttling so the misbehaving service cannot consume the entire quota. This gives all services predictable access to the shared limit. Then I talk to that team immediately with real data to show the impact. Long-term, we need separate keys and dedicated quotas, but in the moment, the priority is fairness, stability, and preventing lateral damage. It is a balance between technical action and interpersonal coordination. Next scenario. Your API is starting to approach its maximum design throughput. You have no hard failures yet, but latency is creeping up and you know the tipping point is close. Management wants to delay infrastructure upgrades due to cost. What is your judgment call? A mature answer would be: I explain that delayed scaling often leads to outages that cost far more than proactive upgrades. I provide concrete numbers. For example, the relationship between saturation and latency is nonlinear. Once you get close to the limit, latency spikes sharply, and even small spikes in traffic can push the system over the edge. I present options ranging from short-term mitigations like caching and reducing response payloads to long-term capacity planning. Ultimately, I advocate for a measured but urgent response. Running a system at the edge is not sustainable and will fail at the worst possible time. Final pressure question. The third-party API that your business absolutely depends on suddenly reduces your allowed rate limit with no warning. Customers begin to experience timeouts. You have no control over this decision. What is your immediate strategy? A composed answer would be, I move the system into protection mode. First, I tighten internal rate limits and prioritize essential requests. Next, I cache aggressively and push non-critical operations to background queues. I communicate the situation clearly to leadership with both short-term steps and long-term options. Those could include batching, negotiation with the provider, or even exploring alternative vendors. In the moment, my goal is to reduce the blast radius so customers experience minimal disruption while we adapt to the new constraints. That brings us to the end of this interview. These scenarios were designed to push your thinking into the kinds of ambiguous and stressful situations that come up in real production environments. Take a moment and reflect on which question challenged you the most. Was it the sudden rate limit reduction, the retry storm scenario, or the shared quota conflict? Your ability to stay calm, reason clearly, and make balanced trade-offs is what separates solid engineers from truly reliable ones. If you want to keep sharpening these skills, subscribe so you do not miss the next interview session.